Solvent extraction is used in purifying or separating substances based on their solubility. It involves using a solvent to dissolve one or more compounds from a mixture and then separating the dissolved compounds from the mixture. And this is what this experiment is going to be focused on: solvent extraction. Now, the distribution of the dissolved compounds at equilibrium point is represented by the equilibrium constant. Now, if for example a chemical reaction as this, A plus B giving you C plus D, with stoichiometric ratios of equilibrium for a reaction as this, the forward and backward reaction are said to be equal. Now, to express the equilibrium constant of such reaction, you can employ this equation that has to do with the product divided by the reactant, while taking into consideration the stoichiometric coefficient. So in this experiment, the concentration of iodine in the organic and aqueous phase for the reaction here represented, whose equilibrium constant is known and has been assumed to be 40, would be determined. Now, since iodine dissolves readily in tetrachloroethane, being the organic phase, but it's less soluble in water, now the addition of potassium iodide would help to foster its solubility in water. Now that means the addition of potassium iodide to iodine is going to form the potassium triiodide, which is soluble in water. And in aqueous solution, the potassium triiodide dissociates into the potassium ion and the triiodide ion. For a dilute solution, the equilibrium constant is expressed using this equation. You can see the product to the reactant, the concentration of the potassium triiodide to the concentration of the potassium iodide, and that of the iodine, the solid iodine, that you would have to weigh. So you can have the equilibrium constant expressed in this way. Now, since the potassium triiodide, the iodide present in it is soluble in water, so that means the triiodide is soluble in both the aqueous phase and the organic phase due to the addition of the potassium iodide to the weighed solid iodine. Now, this occurrence obeys what is called the distribution law, where we have the potassium triiodide and the potassium iodide to serve as our electrolytes and are both insoluble in tetrachloroethane. So here you have a stepwise procedure in order for you to carry out this experiment and report accordingly according to the tables that has been presented in your report manuals.